Hey, welcome. Today we're going to build a program that converts binary to decimal and decimal to binary. So, let's get into VS Code. First, I need to right-click and create my file. I'm going to name this file binary_converter.py. Remember, we need that py extension, so the computer knows it is dealing with a Python file. Before I even write a single line of code, I need a plan. Some idea of how I intend to build this program. I will break it down into a series of smaller steps. That is a key skill when it comes to programming, taking a big problem, break it down into smaller problems, then break those smaller problems down again. So, I'll begin by adding in comments. These are ignored when your program is run, so I'll use these as a kind of guideline. First thing I want to do is ask the user to make a choice. This program will convert both binary to decimal and decimal to binary. So, we need to ask the user which calculation they want to perform. If they choose to convert binary to decimal, then we are going to need a function to deal with that calculation. An important note about functions is they must be defined before they are called. That means, you have to build your function first and call the function lower down in the page. This is because the computer reads your code line by line by line. It only knows what it has read so far, so if you called a function that is defined further down the page, the computer won't know it exists yet and you'll get an error. We will also want a second function. This one will convert decimal to binary. So only one of these functions will ever run each time the program is run, and that will depend on the choice the user made. We also want to check for a valid choice made by the user. We will build this so that if a user enters an uppercase or lowercase b, we will run the binary to decimal function. If they enter an uppercase or lowercase d, we will run the decimal to binary conversion. And anything else, so if they input anything other than those characters, we shall regard this as an invalid input. And right at the bottom of our code, the final task is to print the result. This will be the result of whatever calculation they asked us to perform. With that, we now have 5 distinct problems to deal with. Each of these is manageable with a small chunk of code. So, let's complete our first section. Getting an input from the user and storing that. We will store that in a variable called choice. And we will ask them to press B if they want to convert from binary to decimal, and to press D if they want to convert decimal to binary. We won't worry just now about asking specifically for an uppercase or lowercase b or d. We'll just check for both of those later in the code. So, we should have choice equals input, parentheses, and inside the parenthesis we want quotation marks, and inside the quotation marks we'll tell the user, if you want to convert binary to decimal press B, if you want to convert decimal to binary press D. We will have to check their input for a valid entry, but we will do that later on. This is called input validation. But what we will do here is create a second variable, and we will set its value to false. No quotation marks this time as this is not a string. This is a Boolean value. Booleans are only ever true or false. We want ours to be false because we will create a loop that will always run when valid is equal to false. Since we always want to run the loop at least once, we will initialize valid as false. So, for this, we should have valid equals false. No quotation marks and false should begin with an uppercase F. This means we'll have a loop. Our loop checks the variable valid, and if it is false, which it will be the first time around, it will run the code inside. Inside this loop we can then check the user input. If the user input is valid, we will change the variable valid to true and call whichever function we need. Changing the value to true is essential to exit the loop. If not, we'll be stuck in an infinite loop. And nobody wants that. And that is everything we need in this top section. We asked the user for input. We've stored that in a variable called choice. We've created a variable called valid and we have set its value to false. Only 2 lines of code for this section. Of course, the other sections will need a little more, but at most, each section will require 15 lines of code. Breaking it down this way will make it much easier to understand. With this section done, I'm just going to comment in a line of asterisks to use as a separator. All of this extra space and separators and comments really isn't necessary, it just makes the code easier to read and understand what is going on. Hopefully, that means if you're following along and typing in all the comments, you'll be able to revisit this code in the future and be able to figure out what is going on, even if you have forgotten a lot of the code. I'm also, right at the bottom, below the print the result comment, add in a print statement. Print, parenthesis, and inside the parenthesis result. This will print whatever value is contained in the variable result. We haven't created this variable yet, but, at the end, this will contain the result of whichever, of the 2 calculations, we carried out. It can then print that result to the console, for the user, and our program ends. I'm going to copy that line of asterisks and paste that in some more places. I really want to separate the sections, visually, to make the code as reader-friendly as possible. We started with 5 sections, and now 2 of them are complete. Yep, that final section was nothing more than the single print statement. Now we head straight into creating a while loop. This will run repeatedly, while the variable valid contains false. We want while valid double equals false and a colon, where the single equals sign is an assignment operator that assigns the value to its right to the variable on its left. The double equals sign checks for equality. Is the value to its right the same as to its left? In our case, right now, it is checking if the contents of the variable valid are the same as the Boolean value of false, and it is. Because we initialized it as false. Now, we need to decide what to do if the user chooses a B. And, since we're asking what to do if the user chooses B, that indicates we need an if statement. Inside that if statement we need to do 2 things. First, we need to change the value of the variable valid, and second, we need to call the function that will carry out the binary to decimal conversion. So, we'll say if, and then in parenthesis, choice, double equals, B, and we want the B to be in quotation marks as we are checking a string. While also type OR. This means it will check both sides of the OR statement, and if either is true then the code inside will run. OR, choice, double equals, and an uppercase B. So, we are checking if the user inputted a lowercase or an uppercase b, and if so, we would run the code inside this if statement. And we must remember to end this with a colon. But what do we want to do inside this conditional statement? Well, we need to do something with our valid variable, and we need to call a function. We haven't created it yet. I will call the function bin_dec. This indicates that it is our binary to decimal function, or at least it will be. And when calling a function, we have to add a pair of empty parentheses. I can copy this function, along with its comments, and paste it below. We have 2 checks to carry out. We will change this second if to an elif. E-L-I-F. This means else if. Only if the code in the if statement doesn't run, will this be checked. In here we will change it to check for a lowercase, or an uppercase d, instead of a b. Currently, we are setting the value of our valid variable to our function. We don't want to do that. What we do want is to change valid to true. Since this code only runs if the user entered a b, and the else if runs if the user entered a d. These are both valid inputs, so we will want to call our functions and exit out of the while loop. Below this, we will create a variable and call it result. If you remember, this is the variable that we are printing to the console as the final result. We want to set this equal to something, and this is where we will call our functions. That means when this code runs, it will set valid to true, then move to line of result. It will then run the function and store whatever value the function returns into the variable result. For our if choice equals b statement, we will want to call the function bin_dec. This will convert binary to decimal. In our elif statement, we want to call the function dec_bin to convert decimal to binary. And remember, when calling a function, to add the empty parentheses. These are used to pass arguments into the function, but we won't cover that in this tutorial. Now we need to think about what happens if they didn't enter a B or a D. In this case, their input is invalid, and we need to print an error message. We will do this inside of an else statement. The else statement is followed by just a colon. We are not performing any checks. This code will run any time the if statement and the elif statement don't run. We don't need to change the value of the valid variable here. Since the user did not enter a valid input, valid remains false. We want to print an error message. In this message, we can just say you failed to enter a valid choice. Also, since this is a while loop, it will now repeat. We don't want it to check the user's current choice again. We need them to make a new choice. So, we'll copy our line of code, choice equals input, and paste it here. Now, it will ask the user for another choice, then run again to check for a B or a D. It will repeat this process until the user gives us a valid input. Now it is time to create our functions. To create a function, we use def, this means define. And we type our function name followed by the parenthesis and the colon. For our first section, we'll type def bin_dec, parenthesis and a colon. On the next line, which must be tabbed inwards, we will just put in a return statement for now. We will return the string hello. This will be our binary to decimal function that carries out the calculation. For our second function, we will type def dec_bin. This will be our decimal to binary function. For this one, we will return the string howdy. By just giving them different strings to return, we can now check our while statement is working properly. So, to test this, we need to go into the Run menu at the top, and we'll select Run without debugging. If all goes well, we will get our first prompt asking us to enter a B or a D. I'm going to first enter a G, and I get the error message. It now asks me again. This is exactly what we wanted to happen. I'll enter a 6, another error, great. Okay, let's type in a valid response, D, and I get howdy. So, I know it called the function and returned the result. And I'll just run it again and try entering a B, and now I get hello. So far everything is working as it should. So, we know that at this stage, 3 of our initial 5 problems have been solved. All that is left to do is turn these 2 functions into something that do a calculation and return the result. First thing we want in our binary to decimal function is to get a new input from the user. We now want them to enter a binary number. We will store this number in a variable we will call binary_choice. And, of course, set that equal to input, with our prompt to the user. We will also need to know the length of the string of ones and zeros they enter. Remember, even though we want a binary number, so the user should only enter ones and zeros, this will still be stored as a string. We will have a variable called number of bits. We will set this equal to the length of the string using len and parenthesis. This stands for length, and it will count the number of characters of whatever is placed inside our parenthesis, and inside the parenthesis entering our binary choice variable. This will count the number of characters entered and then store that value, as an integer, in our number of bits variable. So, if the user enters 1, 1, 0, 0, 1, 1, it will store the integer 6 in our variable as there are 6 characters. And we want one more variable before we go converting, and that is to store the resulting decimal number in. So, I'll name this decimal underscore number. And I want to initialize it as 0. This will start at 0, then we can add the value of each binary digit to it. Then, at the end of the loop, this will become the decimal equivalent of the binary number. We are now ready to create a loop to carry out our binary to decimal calculation. Because we have created the decimal number variable, and we know that this is where our final result will be stored, we should now remove that hello string from the return statement and replace it with our decimal number variable. So, when our function ends, it will now return whatever value is in that variable so that our final print statement can print the result. We will be converting this number one character at a time. So, we want to create a loop that will run once for every binary digit the user entered. If they enter 1, 0, 1, it will run 3 times. If they enter 1, 1, 1, 1, it will run 4 times. And so on. Let's create a for loop. I'll type for bin underscore digit in range, then parenthesis. Inside the parenthesis, I'll put a 0, comma, as I want the loop to start on 0, and then our number of bits variable. This means that our loop will run how many times it takes to match the number of characters entered by the user. The bin underscore digit acts as a variable that is the loop counter. It is initially 0, then increases by 1 every time the loop is run. We want another variable. We'll name this binary digit and we'll set this equal to our binary choice variable followed by the square brackets. Inside the square brackets we'll place our loop counter, bin digit. This means on the first loop it will take the digit in the 0th place, which will be the first digit. Second loop, bin digit will equal 1, so it will take the next digit along. This is how we will cycle through each of the digits. Now we have isolated the digit we want to work with, we first need to check if it is a 1 or a 0. We'll create a for loop for this. And we will use the not equals operator. Exclamation mark followed by equals sign. This checks if the code is not a 0, and instead of or, we'll use and to check if it is not a 1. If the character is not a 0 and it is not a 1, both of these statements will return true, and the code inside will run. That means, inside this if statement we are dealing with digits that are not binary numbers. In this case we need to identify an error and exit the loop. It's worth paying attention to indentation at this point. The if statement has to be inside the for loop. So tabbed in further. Python is very strict on this. So, to check for errors and exit the loop, I will put in the variable digit underscore value. This is the variable we will use to hold the decimal value of each binary digit for when we add it to the decimal value. Since we know that this should always be equal to 0 or greater, here I will set it to equal -1. We can check this later, and if it equals -1, we know we need to print an error message to the user. The other thing we need inside this if statement is a break statement. This is just the word break. This will exit the loop, and we know that if we are dealing with a non-binary digit, then we cannot complete the calculation, so we should stop here. And that completes this if statement. In the event that the user enters anything other than a binary number, this will run, set a negative value to the digit value variable and break out of the loop. In our else statement, we can now, finally, convert the binary digit into a decimal number. So, let's create an else statement and do some math. We are working with the current digit in the loop, and we need to multiply that by 2 to the power of something to get the decimal equivalent. How do we find out what power of 2 to multiply by? Fortunately, a string is similar to an array, in that each character can be accessed by its index. Indexes start at 0, for the first digit, the 1 for the second, and so on. Same as our loop. We also already know the length of our string. So, if our string is 4 characters long, that first digit would be in the 8 place, in a binary string. That means we have to multiply our 1 by 2 to the power of 3. We can achieve this by first converting the binary digit to int. See, we need numbers to do calculations. Then we multiply it by 2, using an asterisk, then we add 2 asterisks for a power. Inside some parenthesis, we're using BIDMAS here, we'll have number of bits variable, minus bin digit, the current loop count, -1. This means that our digit will always be multiplied by the correct power of 2. And we will store the result of this calculation in our variable digit value. You should end up with digit value equals int binary digit asterisk 2, 2 asterisks to state a power. Then in brackets, number of bits, minus, bin digit, -1. Once you have that, that is the calculation done for this digit. The whole purpose of our program boils down to this one-line calculation. If it seems complicated at first, don't worry. Go over the code a couple of times or have a look at a binary table that explains the powers of 2 in relation to binary. Failing that, just copy the code I have written and trust that it will work. The only thing left to do here is add this digit value, which should now be a decimal number, to our decimal number. We don't want to assign it to decimal number, as that will just overwrite any previously stored number. Instead, we will write decimal number equals decimal number plus digit value. This takes the current value in decimal number, adds it to the value in digit value, then stores the result back in decimal number. And with that done, our for loop is complete. It will now cycle through every binary digit entered, convert it to decimal and output the resulting decimal number. It will also, if a non-valid character is entered, identify the error and exit the loop. We just need 2 more lines of code to check for the error and print out an error message. If you're feeling confident, pause the video and see if you can complete those 2 lines of code. We will have an if statement to check for the error, and we will enter if digit value double equals, so is the same as -1, colon. This will check for that -1 we set in the previous if statement. If it returns true, we'll just print our error message to the user. And our binary conversion is complete. Of course, we still need to convert our decimal numbers to binary, but it is still worth celebrating getting this far. To summarize what we have done, our for loop runs once for every digit entered. It isolates a single digit from what the user entered. It then checks to ensure that the digit is a valid binary digit, and if it is not a 0 and it is not 1, then it breaks out of the loop. If it is a valid binary digit, it will multiply it by a power of 2, which is calculated using the string length and loop counter. It stores this value in a variable and finally adds this to a running total in the decimal value variable. It then kindly returns the resulting decimal value to the variable that called the function. So now let's run the program and convert something. I will click Run without debugging, and first, at the prompt I'll type an invalid input. There is the error message. Now I'll type a B for the binary to decimal conversion. I'll give it the number 1, 0, 1, 1, 1, 0, 0, 0, 1. And I get the result 369. And yeah, I have no idea if that is correct and do not want to do the math to check it. So, I will cheat. I'm going to visit Google, search for a binary to decimal converter, and just copy in the number I just tested. And it was spot on. Excellent. Now, we have only one more section to do. Take in a decimal number and output its binary equivalent. So straight away, I'll type binary in the return statement. That is what we want to return. This will be an array of the binary digits we end up with. And I don't think we need this in parentheses, so I'll remove them. I'll remove them from the return statement in our other function too. So binary in our return statement, we will need to create that variable. We will do that very soon, and initially it will be an empty array. If all goes well, it will be an array containing only ones and zeros. Before that, as we did in the other function, we need to ask the user for an input. We should store that in a variable called decimal underscore choice. This will just be another input statement, this time asking for a decimal number. Whole numbers only. This video is long enough without converting floating point numbers into binary. So, we'll have decimal choice equals input. And we'll say please enter a decimal number. Whole numbers and integers only. When it comes to prompting for input, it always pays to be as clear as possible, to try to get the user to give a valid input the first time around. We still have to code for all the potential errors, but it does serve to make the program more user-friendly. Next up, we need to ensure that they entered a decimal number. This is much easier than checking the binary input. Python has a method called isNumeric that returns true if every character is a number from 0 to 9. So even if the user enters 2.5, it will return as invalid as the decimal point is not numeric. So, we can type if decimal choice dot is numeric and parenthesis. Because we always add parenthesis after a method. This means that whatever code runs inside this if statement will only run if they entered a valid integer, a whole number. Anything other than a whole number will be regarded as an invalid input, and we'll deal with that later with an else statement. We need to think about how we can convert our decimal number to a binary number. What we currently have is a decimal number. It is stored as a string. Because input always stores as a string by default, we will need to convert it to an integer to do calculations. But we want to return a string, more specifically, a string of ones and zeros. To achieve this, we will use an array. An array is like a list of items. Think of a variable as a box you can put something in. An array is a bigger box you can put multiple items in. Each item in the box will have a label, known as an index. This starts at 0, and counts up by 1 for each item in the array. So, we'll say if decimal number dot is numeric, parenthesis, colon. The first thing we'll do inside this if statement is check if the user entered a 0. If they only entered 0, well, binary 0 and decimal 0 are the same, so we don't need to do any calculations. So, we can say, if decimal number double equals, as we're checking for equality, 0. If this returns true, then that is our calculation complete for 0, and we can just return 0 with a return statement. And we will want our decimal number converted to an integer, as the string 0 is not the same as the integer 0. So, we must remember to say int, open parenthesis, decimal choice, close parenthesis, double equals, 0. This now converts the string to an integer, checks if it is 0, and if it is, returns 0. With that check complete, we now know that we have a valid integer greater than 0. So now it is time to really think about converting this to our string of binary digits. We need to store our binary digits somewhere, so we'll create a variable called binary, and we can assign this as an empty array by just using a pair of square brackets. If you look at our final return statement, you'll see that this is the array that will hold our final result and be returned to the user. Now, we have our valid input, we know it is an integer, and that it is greater than 0. We have our empty binary array created, ready for the digits. But our decimal number is still a string. Let's fix that. Converted it to an integer is easy, we just say decimal number equals int decimal number. This takes the string decimal number, converts it to an integer, and stores it back into the decimal number variable as an integer. I keep saying decimal number, when what I mean is decimal choice. Because it is our variable named decimal choice that we are working with. Decimal choice equals int decimal choice. Now to decide how to run our calculation. Well, we will calculate the smallest binary digit first, so, is there a bit in the ones place? And we'll repeat this process as long as our decimal choice variable is greater than 0. So, we want a while loop, and we are checking if decimal choice is greater than, using the greater than operator, 0. Now let's look at the actual calculation we need to use. For example, if our user entered the number 100. If we divide this by 2, we get a 50, with a remainder of 0. That remainder of 0 is our first binary digit. Next, we divide the 50 by 2, to get 25. Again, we have no remainder, so another 0, that we add in front of our existing binary digit. We now have 0, 0. 25 dividing by 2, this gives us 12 with a remainder of 1. Adding that 1 in front of our binary digit gives us 1, 0, 0. 12 divided by 2 gives us 6 with a remainder of 0, so we're at 0, 1, 0, 0. 6 divided by 2, 3 with a remainder of 0. 0, 0, 1, 0, 0. 3 divided by 2 gives us 1 with a remainder of 1. So, we're at 1, 0, 0, 1, 0, 0. Finally, 1 divided by 2 gives us 0 with a remainder of 1. As 2 goes into 1 0 times and 1 remains. Our final binary number is 1, 1, 0, 0, 1, 0, 0. Which is equal to 100. So, all we are doing is dividing our decimal number by 2 and using the modulus operator to check what the remainder is. Because we are dividing by 2, the remainder will always be 0, for an even number and 1 for an odd number. This works out perfectly for us as we only want 1s and 0s. We need to do a couple of things with this remainder. We want to add it to our binary array. We do this with binary.insert and parentheses. Inside the parentheses will start with 0, comma. This ensures each new digit is placed before the previous digit at index place 0. All the other digits will move to the right one place. Then we want str, parentheses, as we want to convert our digit back to a string. And inside our string parenthesis we'll put our decimal choice variable, modulus, using the %sign, 2. This is now taking the remainder of our decimal choice variable, whether it is a 1 or 0, and adding it at the index 0 place of our binary array. Breaking this one line of code down, we are saying binary, because this is the name of our array. Then we're saying, insert, parentheses. This is calling the insert method to insert something into our array. Inside the insert parenthesis we are passing two arguments. First, we are saying 0. Because we want our digit placed in the 0th place every time. Then we are saying, get the remainder of the decimal choice variable when it is divided by 2, and we're using the modulus operator for this. Finally, we're putting that inside of a string method to convert the result to string. Every time this is run, it will add a 1 or a 0 to the front of our binary array. And because this is in a while loop that will run repeatedly while decimal number is greater than 0, then this will keep adding as many digits as it needs to. We have only one more task inside this while loop. So far we have got the modulus of the decimal choice variable, but, if we ran this now, the decimal choice variable would always be greater than 0, because we never change it. We would be stuck in an infinite loop that just keeps adding the digit to the binary array over and over again. So, we have to do something to the decimal choice variable to ensure that our loop ends, but also that the second and third iteration of the loop provide the correct binary digit. Luckily, this is as simple as dividing the decimal number by 2. We do have to be careful though. If we have an odd number, and we divide by 2, then we will end up with something 0.5. A floating point number. We want to stick with whole numbers only. For this, we use something called floored division. We do this with 2 forward slashes. 1 forward slash is for a standard division, and 2 is floored division. Floored division means it will divide by 2, but only keep the whole number part of the result and disregard anything after a decimal. So, 25 divided by 2, using floored division, would give us 12. Since the accurate answer would be 12.5, but we have ignored the 0.5. In fact, in our case, that 0.5 will have signified a remainder of 1 and been included in a binary array. With this, we also know that on each iteration of the while loop, our decimal number will get smaller. So, we can rest assured that the loop will always end eventually. So, in our example we used previously, the user enters 100. The first time the loop runs it calculates the remainder of 100 divided by 2, then we halve the 100, store that in our decimal number, then on the second iteration of the loop it calculates the remainder of 50 divided by 2. So on. And that completes our calculation for our binary digit. Our while loop is complete. It will now take any decimal number and create an array of binary digits that create the equivalent binary number. We have covered a lot so far, so take a minute to think about how our program is working. If there is anything you don't understand, maybe go over the video again. Or if you want something explained in more detail, then pop a question in the comments section. We now want to return something. I want to return the binary array, but I don't want it to return a list of individual digits. I want to join them into one string of binary digits. So, outside of the while loop, but remaining inside our if statement. This means you should be tabbed inwards 2 times. We will put a return statement. And we will type a pair of quotation marks, with nothing in between them, join. And then in parentheses our binary variable. This is going to join all our array items with nothing in between them. That pair of empty quotation marks is where we are saying we want nothing separating each digit. We are so close to being finished now. Our very last task is to create that else statement to print an error message if the user enters anything other than an integer. We've already checked for a valid user input and ran the code need we to for that. So, our else statement can simply print an error message to the user informing them that they didn't enter a valid number. And then, once you have added the else statement, put in a print message for the user. The binary to decimal and decimal to binary converter is complete. You have done it. Using Python, you have built a program that uses, for loops, if statements, while loops, variables, arrays, functions and methods. This program touches on so many aspects of Python. That makes it a great beginner project. I will add some more comments, tidy up the code, maybe add another empty print statement to make the output a little nicer in the console. I want someone, who knows no Python, to be able to read through the lines of code just using the comments, be able to understand what is going on. I will make this finished program available on GitHub. While you're much better off following along and coding it yourself, it might be handy to have the code available if you run into difficulties, so you can compare your code to mine. Now we can move on to testing our program. I will run it and enter the same binary digit I entered before. I select D, and enter the number. And I got a crazy long number. I see what I did. I converted from decimal to binary, so the program used 10110001 as a decimal number and convert it into a very long binary number. Let's do it again, properly this time. Selecting B, the correct conversion, I get 369 as the result, which I already know is correct. I'll run it again. This time I'll select B but enter an invalid number. And I get the error message. You'll see it printed 02. This is because we initialized our variable at 0 and still returned it to the print statement. Play around with, convert big numbers, small numbers. I could convert a very, very long string of binary digits and get a very large decimal number. Our program can cope with any size integer or binary number. So congratulations on reaching the end. With a bit of luck you've learned a lot from completing this project. Hopefully you followed along and now have a working binary to decimal converter. And hopefully you feel a sense of accomplishment. This was really quite a large project for a beginner project. Remember to post any queries in the comments. If you'd like to see how a particular program is built, then let me know. I may look at creating a simple game next. Something with a more graphical interface. If that is something you'd be interested in, then like and subscribe. Thanks for watching. I have many more tutorials planned. Not just for Python but also web development and some of the newer languages like Kotlin, Go, and Scala. Bye for now. Hope to see you at the next tutorial.